one? All right, so the next one. Again, first thing we do is make sure they're in order. They're in order. Next thing you check is to make sure nothing's missing. Do you see anything that's missing?
Yeah.
What's missing? So I'm just going to make a little note to myself here. 0x squared is missing. I'm going to have to put that in when I put in all my coefficients. So then, what number goes in the box?
-2.
-2 goes in the box. What's my first coefficient?
1.
Then the 0, then -7 and -6. What's my first step after I get it set up? Drop down the first number. The 1 comes down. Once it's underneath, multiply. 1 times -2 is -2. Add down, -2. -2 times -2 is 4. Add down, -3. -3 times -2. What do you notice about our remainder? There's no remainder. So then we just write out our polynomial from there. What degree is this going to start with?
X squared.
How do I know it starts with x squared? You go 1 less than the original. So you always need to look back at the original. The original was cubed, so I'm going 1 less than that. It's going to start with x squared. If it had started with x to the 4th, what would my answer start with?
X cubed.
X cubed. Good? So the last things we're looking at, we're going to do 2 more problems together, is two different versions of problems, 2 different types of problems that use synthetic division, but then you're going to have to answer the question. Instead of just telling me what the polynomial is at the end, you're going to have to answer the question. So the first one revolves around what's called the remainder theorem. The remainder theorem says that if you take a polynomial function and divide it by x minus something, that's the same thing as finding the value of that function and inputting whatever that something is into the equation. So for instance, when you look at this example, they gave you the function, they want you to find, your directions right now are to find f of -4. Before today, what would you do when I say find f of -4? You plug it in, okay? Well, plugging it in, if you think really back to when something like this, the remainder theorem was created, it's back way before calculators were invented. Plugging in -4 right now is not a whole lot of fun, especially as you get to bigger numbers, it's not a whole lot of fun. So this was an alternative method to getting the answer to this without having to plug it in. All you have to do is do synthetic division with that number. So when I set this up, the one thing you have to be careful about is this is already the 0. The 0 is -4, so that number is going to stay the same. It's only when it's with the x. When it's x plus 4, you would change it to -4. Or if it's x minus 7, you would change it to +7. But right now, that is a 0. You're just going to put -4 there. And then just double check, do we have any skip terms? No. So then we can just write down 3, 4, -5, and 3. I'll give you a minute. See if you can work through that. So I'm going to work through this. So the first step is to bring down that 3. 3 times -4 is -12. 4 plus -12 is -8. Just watch your signs when you multiply. This is now positive 32, 27, and then you get -108. So when you add down, you get -105. But now you have to pay attention to what they asked you for. They asked you to find, our goal is to find what f of -4 is. This is where the remainder theorem comes in. The remainder theorem says f of that value is just the remainder of this answer. What's the remainder? That's your answer. So f of -4 is going to equal -105. If you wanted to check it, you could plug -4 into that function. But this math, because you're just adding and multiplying, is easier than actually plugging in -4 and cubing it and squaring it and making sure you're doing your order of operations correct and your signs are coming out correct. So this was just an alternative method that mathematicians came up with to finding the answer by plugging in -4. Okay, so that's what when it says use the remainder theorem, you're dividing, and the remainder is your answer. That should make sense, right? If it says remainder theorem, that the remainder is your answer. a number here.
Wait, how was 7
It's not.
It's not the factor.
He was giving an example.
If I gave you this number right now, and I asked you without a calculator to break that down, can you? Can you factor that down?
If you add it,
It would take you a while without a calculator, right? What if I told you one of the factors is 13? I'm going to make it even easier on you.
13 and then figure
What would you do?
Divide by 13.
You would divide by 13, right? So I would do this divided by 13. That would be my first step, is I'm going to divide first to figure out what that is. I'll tell you that's 99. I'll be your calculator. Do you see what that did now? Doesn't that make it a whole lot? So then you could finish breaking this down, right? It'd be 9 times 11 times 13. Do you see how by giving you one factor, I made it all that much easier to factor? That's what we're going to be working on in this problem. Right now, if I asked you, they want you to solve your goal in the end, so you got to pay attention to what the question asks. You need to be able to solve this equation. If you looked at that polynomial function, what method do you have right now to be able to solve it? Before we did that, before I taught you that, if you looked at this, how would you try to solve that? Factoring, right? Watch what happens if we try and factor this. What did I take out of the first group?
X squared.
Times 15x plus 14. What can I take out of the other group?
1.
Do these end up matching like they're supposed to? So what we're looking at is methods to solve problems that we can't actually factor. Factoring doesn't work here. So we need to come up with another method. Well, this is where they gave us this. We're going to talk about later this week what happens when they don't give it to us, how we can find it. But they're giving you a factor in their homework tonight. So if they give you a factor, what's your first step? When I gave you 13 before, what did you do with it first?
Take it out and then figure out
What operation did we do with the 13? We divided, right? So now you need to divide, but now you're dividing a polynomial. So we're dividing with that -1. That is the 0. So I put the -1 here, and we're just going to divide. If it's a factor, I can divide it by that, can't I?
Yes. Oh,
They gave me the -1. I'm using the -1 they gave you.
okay.
It's like when I gave you the 13. 13 allowed you to break it down smaller. That's what we're doing with the -1. We're going to break this down smaller. 15 comes down.
Yeah.
-15, -1, 1, -2. Notice what our remainder is. What told me that that should be 0? It's a factor. So the remainder here should always be 0 when they tell you it's a factor. So now we have to answer the question. The question still said solve. So I need to write this out as a polynomial. It's going to start 15x squared minus 1x minus 2. I need to solve that. How do I solve that? I can first set it equal to 0, and then I am going to factor it. Factors of, what's the top number?
Negative. Oh, yeah.
Negative 30 that add to -1, 6 and 5, and which one's got to be negative?
6.
-6 to get -1. It's being real slow up there. Then what? Are you paying attention to how we have to factor this?
15x squared minus.
We gotta split it
4
apart?
plus 5x.
15x squared, I would put the 5 first because it goes nicer with the 15. Minus 6x minus 2. And group them. 5x times 3x plus 1 minus 2. 3x plus 1. 5x minus 2 times 3x plus 1. And I lost my equals 0 there. Should we bring it down? Because now I can just set them equal to 0, right?
X equals 2 over
X equals 2 over 5.
Negative 1/3.
X equals negative 1/3. But how many answers were they supposed to have here?
Three.
If you looked back, aren't there supposed to be
So
3?
negative one.
Wait, dude, yeah.
There's supposed to be 3 because it was to the third power. You also need to include.
From when you started with, you did not.
Mm-hmm.
Wait, so for this one, we don't, wait, what was the one where you said like it's 1 over? If it's like x to the 3, then we know that this.
So, and then negative 1.
If you're counting terms. So it'd be 2/5, negative 1/3, and the one they gave me. Those are the answers. When you look in the back of the book, they're going to have 3 of them. You need to make sure you have all 3 of them.
So you're just finding the zero?
You're just finding the zeros. So remember, solve means the same thing as finding the zeros. So the word zeros makes more sense to you. It kind of makes more sense to me because it makes me set things equal to 0 when I hear the word zeros. So that's the same thing.